All right, let's get into it. Today, we are cracking open the case on one of the most important little pieces of silicon ever made, the Intel 8086 microprocessor. We're going to find out exactly what made this thing tick and why it was such a monumental deal.
So, picture this. It's 1978, and this chip hits the scene and just completely rewrites the rules. This was the blueprint, the granddaddy of the processors that are inside pretty much every PC and laptop we use today. It kicked off the entire x86 dynasty. But the craziest part? Its origin story. You see, this game-changing chip was never meant to be the star of the show. No way. It was actually just a stopgap, a quick little side project to hold things over while Intel was working on its real next-generation chip, which was super ambitious and super delayed. The 8086 was the backup plan that accidentally became the future. So before we dive into the nitty-gritty of its architecture, we really need to get a feel for what a massive, massive leap this chip was. Understanding its place in history is totally key to understanding why its design was so brilliant. I mean, just look at the jump here. We were cruising along with 8-bit processors like the 8080 and 8085, which could handle about 64 kilobytes of memory. Then bam, the 8086 comes along, a 16-bit beast that could access a whole megabyte. That's a 16 times increase. This wasn't just a minor update, it was a completely different league. Okay, so how does a computer's brain actually talk to the rest of the body? Well, think of the 8086 like a brain in a little black box. It's got these 40 little metal legs called pins, and those pins are its only connection to the outside world. They are its eyes, its ears, and its voice, all in one. Whoa, okay, I know what you're thinking. That looks like a hopelessly complicated mess of wires, right? But don't worry, it's actually way more organized than it looks. We can group these pins into just a few simple categories, and it all starts to make sense. So check this out. These first 16 pins are a perfect example of some really clever engineering. They actually do double duty. To save precious space, the designers made it so these pins sometimes carry a memory address, like a street address for data, and other times they carry the actual data itself. Super efficient. Now these next pins, these are basically the chip's life support. You've got VCC for power and ground to complete the circuit. But the real star here is the CLK or clock pin. This provides a steady, rhythmic pulse, like a heartbeat, that keeps every single operation in perfect sync. Without that heartbeat, the brain just doesn't work. Simple as that. And here's a really cool feature. The 8086 basically has a split personality, and it's all controlled by one single pin. If you set it to minimum mode, it's a lone wolf, perfect for running a simple computer all by itself. But flip that pin to maximum mode, and it becomes a team player, ready to work with other specialized chips in a much more powerful system. Okay, so we've seen how it connects to the world. Now, let's take a journey inside the chip itself, because this is where we find its most revolutionary feature, a brain that's cleverly split into two parts. The whole internal layout is divided into two specialized units. You've got the bus interface unit, or BIU, and the execution unit, or EU. The best way to think about them is like two coworkers who are absolute pros at their individual jobs and work together perfectly. Let's use an analogy here. Think of a master chef and a kitchen assistant. The BIU is the assistant. Its only job is to run to the pantry, which is the computer's memory, grab the next ingredients or instructions, and line them up on the counter. The EU is the master chef. It never leaves its station. It just grabs the next ingredient from the counter, figures out the recipe, and does all the actual cooking, all the calculations. Now, this separation of jobs made a groundbreaking technique possible, and it's called pipelining. This was the 8086's secret weapon for speed. See, with older chips, the processor had to finish one task completely, then stop, and then go fetch the next task. But the 8086 was way smarter. So here's how it works. While the chef, our EU, is busy chopping an onion, the assistant, our BIU, isn't just standing around waiting. It's already running to the pantry to grab the carrots for the next step. It puts them in this little waiting area, a 6-byte queue. The very second the chef finishes the onion, boom, the carrots are right there, ready to go. There's almost zero wasted time. All right, on to the next big trick up the 8886's sleeve, how it managed to organize and find information in that huge 1 megabyte of memory. For a 16-bit chip, this was a serious challenge. So here's the puzzle, right? The 8086's internal notebooks, its registers, are only 16 bits wide. That means the highest number they can hold is about 65,000.
So how in the world could it come up with an address big enough to find one specific byte out of 1 million possible locations?
The solution was just pure genius. Memory segmentation. Instead of trying to give every single byte a unique number from 1 to a million, the 8086 broke the memory up into overlapping segments, kind of like chapters in a book. So to find anything, you just need two things: which chapter it's in, and then the page number within that chapter.
And the math to make this work is beautifully simple. The chip takes the chapter number, which is the segment address, shifts it over a little bit, which is just a fast way of multiplying by 16, and then adds the page number or the offset. And just like that, you get a 20-bit physical address that can point to any single byte in that whole megabyte of memory.
So you've got a clever pin design, a two-part brain that's super efficient, and a really smart way to handle memory. When you put all those pieces together, you don't just get a good chip, you get a legacy that lasts for decades. I mean, when you put the 8086 right next to the chip that came before it, the 8085, the difference is just staggering. This wasn't a small step forward. This was a quantum leap in literally every single category. It was more powerful, more capable, and just way more efficient. In the end, the 8086 wasn't just another successful product. It was the beginning of a new standard. It laid the entire foundation for the x86 architecture that would go on to dominate personal computing for the next 40 years and counting.
Think about that. Every single time you use a PC, you're using a direct descendant of this temporary little chip from 1978. The core ideas we just talked about, that split brain design, the way it handles memory, those concepts are still echoing inside the chips we use today.
And that really leaves you with a fascinating thought, doesn't it? This chip, born out of a project delay, meant to be nothing more than a placeholder, ended up defining an entire era of technology. It's an incredible reminder that sometimes the biggest revolutions don't come from a grand plan, but from a brilliant accident. Thanks for watching.